Okay, so this problem says an airplane flies at an altitude of 5 miles toward a point directly above over the observer. Consider theta and x as shown in the figure. So the first one says to write theta as a function of f, and so in order to do that, we have to use the trig function. So we see that it's x is adjacent to theta and 5 is opposite, so we can use tangent, but because theta is equal to tangent, we have to use the inverse of tangent. That means, to answer the first question, theta x equals arc tangent of 5 over x. It's opposite over adjacent. And so now that we have that, for the second question, the speed of the plane is 324 miles per hour. Find the derivative in radians per hour when x equals 8 and x equals 3 miles, and then round your answers to 3 decimal places. So what you want to do first is you got to find the derivative with respect to theta, or respect to t. And so first, let's do my work up here. We're going to take this equation that we wrote down for theta, the function of x. So we're going to d theta over dt. And then we're going to take the derivative of arc tangent, which is just u prime over 1 plus u squared. And so the derivative of 5 over x is negative 5 over x squared, and that is over 1 plus 5 over x squared. And so because we took the derivative of 5x, we have to add the dx dt, and so the dx dt is going to equal 324 miles per hour, because that's the change. And so we already have x, we already have the dx dt. So to find this right here, we just plug in the numbers. And so when we plug in 8, we get 18.202, and then when we plug in 3, we get 47.647, and this is in radians per hour. And so that is the answer to this problem.